Okay, having issues today. This is my second time to record this. I'm going to try again. This section is going to be on significant figures or sig figs, calculations with those sig figs or measured numbers, and then accuracy and precision. So you need to understand what a significant figure is. A significant figure is a number that you have gotten with measuring, because you have measured something in the lab. Maybe you've measured with a ruler, or you've measured with a graduated cylinder or a balance. It is a measured number, and there are two different kinds of numbers that we can get. We can get exact numbers, things like you've counted how many pencils that you have, or how many months there are in a year. There are 12 months in a year. You don't have to guess at that. That's an exact number. There are 4 quarters in a dollar. That, again, is an exact number. But then there are also ones that are not exact, that you round about. I have about $2 in change in my car. I have about, there are inexact measurements also. So you need to understand the difference in the two. And sometimes it doesn't matter. It doesn't matter if I have exactly $2 in change in my car, unless it does. Now, I don't have any grandchildren yet, but someday I will. And if you are my pharmacist and you are measuring out the medicine for a cough or some sort of sickness that my grandchild has, then yes, it matters. I want you to know exactly how much medicine that you are measuring out for my grandbaby that's yet to be born, that I might one day have. That matters to me. That matters a great, huge amount to me. And the fact that you can do that accurately and do that well matters a very much to me. If you work at Burger King and McDonald's and you can count that you have about 20 French fries in my small French fry, I don't care. It matters how much medicine that you're putting in my future grandchild's bottle. That matters. So there's a big discrepancy of when measurements matter and when they don't matter. I hope you understand that. Okay? So please do understand that significance there, and when it really does matter. When you're measuring for buildings, sure, it matters. It matters. Otherwise, your buildings are not going to come out square. That's why back in the olden days, when they literally did walk-off houses, that's why they didn't always come out exactly, level and square and nice, and that's why, this old house had to fix so many, and you have to shim things and things like that. All right, so there we go. There's a picture in your textbook on page 17 that's of a little flash drive, and this next slide here that's coming up shortly, hopefully, is going to take us and talk to us about sig figs, and the fact that sig figs or significant figures are going to give us an idea of how good a measuring tool that we have to work with. For example, here we have, and let me get into a drawing mode here. Here we have this little flash drive, and we have 2 rulers that we're using to measure it. The ruler at the top is not as good. I hope that you can see that the ruler at the top is not as good as the ruler that's at the bottom. And the ruler at the top, it does not have as many little lines. It is measured in centimeters. The ruler at the bottom, it's measured off in little millimeters. So it is a better, more high quality, more precise measuring instrument than the ruler at the top. So we have to include those certainties in our recordings as we are recording our measurements. So we are going to say this ruler at the top, and to help us here, I'm even going to use my finger and come down a little bit and say we can see that it's past the 2, So we would record that. We can see that exactly for sure that it's past the 2. We know that with certainty. That's called a certain measurement or an exact measurement. And now, how far past the 2 is it? And we're just going to use this little slope. How far past that 2, between the 2 and the 3, would you say that is it 1 pass? Is it 2 pass? And some people would say, oh, it's just 1 pass. And some people would say, oh, it's no 2. So I'm not measuring to the end of the flash drive. I'm only measuring to the corner here where it slopes down. Okay, so maybe it's 2.1, you would say. 2.1 centimeters. Okay, then the bottom, because this is a meaningful digit here, okay, is what the textbook calls it. Let's now measure to this end right here. We can see for certain that it is not only 2 past it, but we can see with certainty that it is, maybe you would say that it's 5 past it. Now then, you not only have to say that it's maybe 5 past it, but is it exactly 5 past it, or is it more than 5 past it? If we were to take our finger and we were to drop it down, is it dead on 5, or are some of you going to say no, that it's, some people are going to say it's 2.50 centimeters, and others of you are going to say no, it didn't quite make it to the 5. It's only 2.49 centimeters. And who's right and who's wrong? Well, both of you are correct. No one is incorrect. Some of you would say that's 2.49. It didn't quite make it to the 5. Some of you are going to say, no, it's 2.50. It's dead on that 5. And either one of you would be okay in your assessment of that measurement. And so you could easily take a piece of paper or something and in your textbook on page 17 and look at that and see. But these are called significant figures, and you are required, and from here on out, I want you to record your significant figures. Every digit you know for sure, plus make a guess. There are also some rules that you are given on page 17 that we're going to look at. And they do trip some students up. But basically, all you need to know is that there are only 2 times that you have to worry about it. And the only 2 times that you have to worry about it is with zeros. And the only 2 times with zeros that you ever have to worry about it is if that 0 comes at the very beginning of the number, or if it becomes at the very end of your number. I've got to stop saying becomes. If the 0 comes at the very beginning of the number, that could have happened because in this case, we recorded for this little disc, we recorded it in centimeters. Well, what if your report that you were filing asked for it in meters? Now you have to change from centimeters into meters, and that is going to require you moving your decimal. And so you're going to have a 0 in the front. Did you measure that 0? No, you did not. So since that 0 did not have anything to do with your actual measurement, it is not significant. Your measurement would be 0.0250 or 0.0249. That 0 that was not measured, so it does not count. So zeros that come at the very, very, very beginning of a measurement, they could have gotten there because you changed units. They never, ever, ever count as being significant. Never. So zeros at the beginning of a number will never count. Whether that 0 is in front of or behind a decimal, they never count if zeros are the very first things that you come to in a number. They do not ever count. Now, zeros in the middle, they always count. It's only zeros in the front and the back that give students trouble. Okay? The other time is zeros at the very end. Zeros at the very end of a number also give students difficulties. And they are the ones that are the ifs. If there is a decimal anywhere in that number, then yes, zeros at the end count. And that's how I tell myself. Is there a decimal at the end? Yes. If there's a decimal anywhere in that number and zeros at the end, then yes, those zeros at the end do count. No, there's no decimal. No, those zeros at the end do not count. That's how it works. Yes, there's a decimal. Yes, zeros at the end count. No, there's no decimal. No, zeros at the end do not count. So that's what rule number 3 and 4 are telling you. Rule number 3 is talking about zeros that are at the beginning of a number. Rule number 4 is talking about zeros that are at the end of a number that contains a decimal. That's what rule number 4 is talking about. And then rule number 5 is talking about zeros that do not have a decimal in them. Okay? If they do not contain a decimal, then they are not significant. Now, if you write them in scientific notation, you can force them to become significant. If you write them in scientific notation, that is appropriate thing to do, because then if you write them into scientific notation was invented by men to show significant figures, to show those numbers that are significant for that purpose alone, so that there's no miscommunication, so there's no ambiguity, to show, hey, these are the ones I measured, these are the ones that count, the rest don't matter. That's its whole purpose in life. All right? I hope that's clear to you. And then we have a practice problem. The sample problem 1.5, which is on page 17. It gives you some to work. It asks you on page 17 at the very bottom for practice problem 1.5. At the bottom says, what about 443? How many sig figs would that have? 443, there are no zeros in there, so we don't have to worry about that. Since 443 has centimeters, has no zeros, all 3 of those would be significant. So we would say that has 3 significant digits in it, or 3 significant figures. Then look at letter B right there, 15.03. There has also no nothing at the beginning or at the end, no zeros at the beginning or at the end, so we really should not have to think about that too much. And it does have a 0 in it, but that 0 doesn't come to the beginning or at the end. Zeros in the middle always count, so it has 4 significant figures in it. Now look at C. C has some zeros, but they're at the beginning. And zeros at the beginning, you shouldn't have to think again too much. Zeros at the beginning, they never count as being significant. So those zeros at the beginning, you say, oh, they don't count. So we're only going to count the 3, the 5, and the 6. So there are only 3 significant figures there. Then letter D, that 3.000, and then it's got a 3. That 3 there, they kind of scooted it over. That's a way that some other countries, instead of putting a comma behind a decimal, they put a space. So that 3 is kind of together. So those zeros are in the middle, so they do all count. So there are 5 sig figs in that number. Look at letter E. That 0, it says 50 milliliters. That 0 comes at the end of a number. You have to ask yourself, here's the trickiest ones in my mind. The trickiest ones in my mind because I have a 0 and it's at the end. 0's at the end, you have to ask yourself the question, is there a decimal in that number? No, there's no decimal. No, there's no decimal, so no, they don't count. So there's only 1 sig fig in that number. Only the 5 counts. And then in F, I've got 2 zeros. I've got one in the front and one in the back. One's in the front, they never count. But what about that one in the back? There's one in the back. Is there a decimal anywhere in that number? Yes, there is. So yes, that decimal, that 0 at the end does count. So there are 4 significant figures in that number. 4 sig figs. All right? I hope that you are getting there. All right. And then the last section that we're going to talk about in this video are what about if we need to add or subtract or multiply or divide when we have sig figs involved. When we have to add or subtract or multiply and divide with sig figs involved, then it again goes right back to what about exact and inexact. If you're going to talk about adding or subtracting, let's think about this, if you will. If you are adding or subtracting, it makes good sense that where is your guess? It's always, always, always at the end. So if your guess is at the end, and I'm going to highlight it here, if your guess is at the end, that means that in this top number, that 102.50, that 0 at the end is a guess. And in this bottom number down here, the 0.231, that 1 is already a guess. So when you add these two numbers together, you have this as your guess or your inexact number. And you have this one also is a guess. When you add these two together, this is a guess right here. This 0 and this 3, when you put those two together, that is also a guess. And then you have the 5 and the 2, that's a 7. And then 2 plus 0 is 2, then the 0, and then the 1. So when you put these together, you have these two numbers that are at the end, both of which end up being inexact or guesses, because this top one here was a guess and this one here was a guess. And you are not allowed to have two guesses in your answer. You can't do it. Therefore, you have got to round it off so that you only have one guess. And the shortcut way to do that is this is how I remember it. When I'm adding, there's my A, here's my S. This A stands for add, this S stands for subtract. When I'm adding or subtracting, I look past the decimal. Only when I'm adding and subtracting do I look past the decimal. This one has 2 past the decimal. This one has 3 past the decimal. I have to go to whichever has the fewest past the decimal. And I have to round to that. Since this only has 2 past the decimal, that's as many as I can have in my answer. I'm going to add or subtract just like always. I'm going to get a calculator and I'm going to add or subtract, or I'm going to do it by hand, either way. And then I'm going to round my answer to whichever has the fewest past the decimal when you add or subtract. Now those rules are going to be different for multiplying or dividing. When you multiply or divide, it works on the same principle. You're going to have guesses. You know, you're going to have your last digit's always going to be inexact. But because of the nature of multiplying and dividing, that guess is going to be spread out. It's going to be spread out. And since it's going to be spread out, then you don't look past your decimal. You look total digits when you are multiplying or dividing. And the example that they give you in your textbook about that is on page 19, and it's example, they give you example C, and they also give you example D and E. Now, example E is written in scientific notation, and I hope that you all know how to put scientific notation inside a calculator. I hope that you know how. I need to do a video on just that for you. here we go. When we have this 8.011 times 1.4. See this? This is our guess here, and this is our guess here. When we multiply these, there's our 4, there's our 4, there's our 0, there's our 32. Here, but both this is a guess right here. That's a guess. But also this 4 right here, 1 times 4 is 4. That's going to be a guess. You know, that 4 right there is going to get distributed everywhere we go simply because, oh my gracious, that whole top row was all guesses because that 4 was a guess everywhere through. Every single number in that top row was a guess. And then we do this 1 times 1. I've said that was 4. That was just silly of me. 1 times 1 is 1, and it's still a guess. And so when you're seeing that, this entire top row is all guesses because that 4 was a guess. So everything in that top row was a guess. And then still this 1, because this 1 is a guess, 1 times 1 is 1. And now we get to numbers that we know for sure. They're not going to be guesses. There's 4, there's 5, there's 1, there's 2, and there's 11. Look how many guesses that we're going to have, you know, and then we have 1, 2, 3, 4 numbers past our decimal, so 11.2154. And yet, how many of those are guesses? A lot of those are guesses, and you can only have one guess. So this one is not going to go with how many are past your decimal, like in adding and subtracting. This one's going to have to go with, this only has 2 digits total. 2. This one has 4 digits total. And so you have to go with whichever has the fewest number of digits total. So this can only have 2 digits in our answer. So we're going to round that to 11. That's how that works, because that gets spread out. And I've gone way past my time. So we're going to give you some of those to practice, and you'll have a lot of practicing to do on that. And my next video is going to be on one of the most important things, and that's dimensional analysis. And I'm going to give you lots of practice on that. So you have a good day.